Hey guys, it's Miss Johnson and I'm here to bring you our first notes for Chapter 3. Today we are talking about how to construct and describe a scatterplot. So we are moving into further discussions of two variable quantitative data, how we can graph points of two variable data and look at them on a coordinate plane and analyze them from there. So we get into explanatory and response variables here. When we are talking about two variable data sets, we are looking at two different kinds of variables. One of those variables is going to be the explanatory variable, and one of those variables is going to be the response variable. It says most statistical studies examine data on more than one variable. Analysis of relationships between two variables builds on the same tools that we use to analyze one variable. The response variable is something that measures the outcome of a study. This is typically a variable that's going to be like your Y. Okay, if you were thinking of an independent and dependent relationship back in algebra, when you learned about independent and dependent variables in algebra 2 primarily is where we talked about that, the dependent variable would be your Y. That's what the response variable is in statistics. The explanatory variable is what may predict or explain the changes in the response variable. So explanatory is like what's explaining your data. The response is the result, what happens when the explanatory value does something, when it goes up, when it goes down, whatever may happen. It says, note, in many studies, the goal is to show the changes in one or more explanatory variables that actually cause, this is a key word here, changes in the response variable. However, other explanatory response relationships don't involve direct causation. So we're going to talk a lot about the difference between causation and just a linear relationship or correlation. So when we use a scatter plot to display our data, we are essentially drawing on a coordinate plane. Typically, we're in the first quadrant. If you remember back to coordinate planes, this is quadrant 1, this is quadrant 2, this is 3, this is 4. Okay, we typically live in this world. Okay, most of our data that we deal with is positive. Now, that doesn't mean it can't be negative. It does, there are variables that have negative values, okay? But a lot of times we're living in quadrant 1. So it says the scatter plot shows a relationship or an association between two quantitative variables that are measured on some individuals. The values of one variable appear on the horizontal axis and the values of another variable appear on the vertical axis. Each individual in the set appears as a point throughout the graph. So you're going to graph these things as points, x, comma, y. When you make your scatter plot, you're going to label your axes, tell us what the x-axis is, tell us what the y-axis is. The explanatory, do you like that right there? See how the word explanatory has an x in there? That's going to be on our x-axis. And then the response variable is going to go on the vertical axis or the y-axis. If there's no explanatory variable, then either variable can go on the horizontal axis. Sometimes you don't know what the explanatory variable is. It's like the chicken or the egg, what came first. And so then you just pick one. Scale your axes appropriately, and your x can be different than your y. That's one thing that always throws people off. They always think the x and the y have to be the same. They don't, and in most cases they won't be. And then plot your individual data points. Now, just like everything else in this course, you're going to be so grateful and happy to know that there is a way to do this on your calculator. Woohoo! So when you are graphing 2 points on your calculator, or when you're graphing two variables on your calculator, you're going to go into your stat editor and you're going to use two lists. So you're going to be in typically L1 and L2. That can be your X, that can be your Y. Now, it doesn't matter what list you pick. You just want to be really careful when you go into that stat plot menu to pick the X list and the Y list accordingly. So most often people will use L1 and L2. Go into your stat editor, put your explanatory variable in one of them, put your response variable in the other. Then you go to your stat plot. That's that one that's above the Y equals menu. So if you do second and y equals, you get into your stat plot menu. And then you can turn your plot 1 on, go into plot 1 and just enter all your choices. The very first display in that section is the scatter plot display. That's the display that we're going to use in chapter 3, and that's the display that you're going to use quite a bit throughout the rest of this course. But you're going to look at the scatterplot display. So that's going to ask you, what is your X list, what's your Y list? And then Zoom 9 is really your best friend, this Zoom stat option, okay? That's going to be the best way for you to get your data all in on your window, that you see on your graph. So yeah, from the home screen, in case you forgot to get to your home screen, you can go second and then quit, which is the button right next to second. It's above the mode. That's above the mode button. So second quit takes you to your home screen, and then you can hit zoom and then option 9, and it's going to show you your graph. There they are. All right, so let's talk about how we would describe scatter plots, and then we're going to get into actually doing one on our calculator. So to describe a scatter plot, follow the basic strategy of data analysis from chapter 1. We're going to look for patterns. We're going to look for important departures of the patterns. We're going to talk about whether the relationship is positive or negative. We're going to talk about how strong it is. Is it a strong relationship? Is it a weak relationship? There may be no association. It may be too hard to tell. The relationship between the two variables may be so weak that it's too hard for us to even tell if there is an association at all. So our same things that we would talk about with one data set, we're still going to be talking about with two variables. So describing scatter plots, if I look at this scatter plot on the top left, I would say, let's say I try to draw a line of best fit through here, which is something we're going to do later in chapter 3. I would say that that's a positive association between payroll and number of wins. It might be a fairly weak association. I do see some departures from data. There are some outliers that may be, far off the general pattern, but I would still say that that's a positive association. The next graph over that says number of runs allowed and number of wins, I would say that this is a negative association, okay? So it makes sense in my head if we're talking about a baseball team, which it seems like we're talking about a baseball team. If we're talking about a baseball team, if they allow a bunch of runs, they're probably not going to win, okay? A whole lot. So the less amount of runs that they allow, the more wins they have. Makes sense, right? If they allow a whole lot of runs, they have less wins. That's a negative relationship, okay? It's fairly strong. You would probably have a pretty decent correlation here, which is what we're going to get into for the second half of 3.1. But there are still some departures in data, so I would guess I would use the words fairly strong here. Okay. Not necessarily strong or really strong or whatever. If I look at this one down here, this graph right here, what's happening in this pattern? I have no idea. I couldn't tell you. I don't see any relationship. It says the height and the amount of sleep. So you're trying to determine, is there any sort of relationship between your height and the amount of sleep that you get? You and I both know that there's probably not really a relationship there. There's probably not really anything that dictates what amount of sleep I'm going to get based off of my height. And you can see, like, I can't even tell. Is this positive? I don't know. Is this negative? I don't know. Is it non-linear? I mean, is it no slope? Zero slope? I don't know. So this is one that I would say is no association. Okay, fairly strong. And we would also say fairly strong and negative for that one up there. This one would be, I would say, moderately strong or kind of fairly weak. Fairly weak, I guess. Is that a fair way of saying that? Fairly weak positive association. That's how I might describe that one. All right, so just like we had socks, remember socks? When we had socks for one variable, we have, some people call this duffs. Duffs. for 2-variable. It's a really similar outline for describing your scatter plot. You're going to talk about the direction. So what direction is it going? Is it positive? Is it negative? Or can you not tell? You're going to talk about the form. Is it a linear form or is it some other non-linear? If the form is linear, then you're going to be able to draw a straight line through it. Otherwise, if it could be a curve, it could be exponential, it could be, radical that way. If it's non-linear, then it's going to have some sort of curve to it. You're going to talk about the strength. Is it weak? Is it moderate? Is it strong? And then you're going to talk about any unusual features. That's where you might see any outliers, things that are departures of the pattern. Departures of the overall pattern. Okay. So be careful when, just like with 1-variables, we had to use context quite a bit when we would write up our descriptions of our data sets. When we would write a description of the histogram or a description of the dot plot or whatever it may be, we used the context of the question quite a bit. You have to do that again. When you're describing the association that's in a scatter plot, you have to put it in context of the problem. The College Board exam readers will automatically dock you if you don't put context in your write-ups. All right, so let's talk about how to describe the relationship here. I see that my relationship appears to be negative. It says the scatter plot shows the association between the mean SAT math score and the percent of students who take the SAT out of the 50 United States. Describe the association shown in the scatter plot. So the percent of students taking it and the mean math score, it almost appears as if this relationship looks curved. If I tried to draw a linear line through here, it doesn't seem to follow a straight line. So if you look over at this description right here, it says there is a moderately strong negative curved relationship between the percent of students in a state who take the SAT and the mean SAT math score. Okay, so let's talk about DUFs for a second. DUFs. This was direction, this was form, and this was strength. So look at this phrase right here. Moderately strong, there's your strength. Negative, there's your direction. Curved, there's your form. There's your strength, there's your direction, there's your form. You've got 3 out of the 4 things that you need in the first sentence. Here, right here, between the percent of students in a state who take the SAT and the mean SAT math score. There's your context. Okay, boom, nailed it. First sentence done. Let's take a look at the next sentence down. What's our one variable that is left? Unusual patterns or characteristics or whatever you want to say. Furthermore, there are 2 distinct clusters of states and 2 possible outliers that fall outside the overall pattern. This whole sentence right here is your U. There's your D, there's your U, there's your EF, there's your S, here's your context. Boom. That's what you need for an E. If this were a free response question on your AP exam, that statement right there is what you would need for your E. They're looking at this little cluster right here, by the way, and this little cluster, and they see that outlier and that outlier if you're looking for where they got all of that information. All right, so we talked about how to graph your points in a scatter plot. Remember that you can use your graphing calculator. There is no real need for you to sit and calculate it out on your own. However, if you use your graphing calculator, don't forget to draw it out on your paper. Put on your paper what the scatter plot looks like. Label your axes, scale your axes, okay? Label, scale. Okay, that's going to be important. The AP exam reader is not going to know that you put a scatter plot on your calculator. They're going to want to see this, and so does Miss Johnson. Miss Johnson wants to see you put it on your paper as well. So you're allowed to use your calculator to calculate the scatter plot and to draw the scatter plot for you and to scale the axes for you. That's sometimes the hardest part. Sometimes the most annoying part is just drawing the axes. I like it when my calculator decides those things for me. But you still need to draw it out. Okay, so don't forget to draw what you see on your calculator. And then remember on your calculator. And then remember to use that DUFS. What is the direction, form, strength, and any unusual features that you see on the scatter plot. All right, that's it for today. Thanks for listening, and I will catch you next time.